Okay, so I am starting over here with percent error. So let's go over here. When we make measurements in the lab and we compare them to reference values, like the actual density of something that's in a reference book, we may calculate the percent error, okay? So be really careful. Do not Google the percent error equation because they may give you something slightly different. I have students that do that every year, and it's really obvious when they do because the measured and accepted value get twisted, and then sometimes you'll have absolute value symbols on them. So I'm just telling you that for percent error, we will be using this equation. So the measured value is whatever you get in the lab. Accepted value would be a reference value that I would give you. And then the 100% is called an exact number. I'm going to go over exact numbers in a little bit. Exact numbers come from a few different places, but exact numbers are important because we don't care about how many significant figures there are, which I'm going to talk about in a second. But we don't use the 100% to determine significant figures in our final answer. And I'll go over that, okay? We want to know if we are above or below the true value when we're calculating percent error. So let me give you an example. Let's take a look at the quick check. It says a student weighs a penny and finds that it has a mass of 2.57 grams. So since this person weighed the penny, this mass would be my measured value. Okay. Then it says the data from the U.S. Mint indicates that the average penny from that year should have a mass of 2.46 grams. So the 2.46 grams would be my reference value or my accepted value. Okay. Absolute uncertainty comes from subtracting them and figuring out what the difference is. For instance, it says in your book, the absolute uncertainty refers to exactly how much higher or lower a measured value is than the accepted value, okay? So if you subtract the two, we're going to get an absolute uncertainty of 0.11 grams, okay? So this student is actually 0.11 grams above the accepted value, okay? What's the percent error? Well, we use the equation. So our measured value is 2.57. The accepted is 2.46. Divided by 2.46, and then we multiply by 100. Remember, you follow the order of operations when you're doing problems that have multiple operations in it. So we use PEMDAS. So we do the subtraction step first. 2.57 minus 2.46 is going to give you 0.11. Divided by 2.46, then you would multiply by 100. You're going to end up getting 4.47% for your percent error. Now, you know that the student's mass of the penny was above the accepted value. So when you have a positive percent error, that means we are above the accepted value. And then when you are below the accepted value, you have a negative percent error. Okay, so I'm just making this note so that you guys can look back here when we're doing a lab where you calculate percent error. Oh, go ahead, over on my desk. Okay, are we good with this? Yes? A reasonable source of error here would be, well, one thing is we use two different scales, so they're going to have different rounding. Okay, so that's something that would be a reasonable source of error. All right, can we go to the next page? Yeah. Want me to wait? All right, now let's talk about significant figures. When we're determining the number of digits in a measurement that are certain plus an uncertain digit, we're looking at something called significant figures. There are various rules for determining significant figures, and you have to know them. Okay, and we have a practice worksheet to go with this. So what we're going to try first is we're going to count significant figures in measurements. Okay? And I'm going to give you examples as we go. Non-zero digits, meaning the digits 1 through 9, are significant. Okay? Let me give you an example. 56 grams. The 5 and the 6 are significant. I would have 2 significant digits. Okay? When you tell me how many significant digits you have, you don't put a unit on it. It would just be 2. Okay? And then sometimes you'll see them underline the digits that are significant to help them keep track. Because later on, we're going to use this to do different operations. Okay? Number 2, zeros between non-zero digits are significant. So that means if you have something like 506 grams or 2002 grams, those would be zeros that are trapped in between the digits 1 through 9. Okay? So we often call these sandwiched or captive or trapped zeros. So in 506 grams, I have 3 significant figures. Okay? In 2002, I've got 4 significant figures. Okay? Third rule, leading zeros. These are zeros to the left of a non-zero digit. These are never, ever significant. So if you have something like 0.26 grams, the 0 in front of the decimal point is not significant, but the 2 and the 6 are. So that means I have 2 sig figs. If you have 0.001 grams, those zeros in front of the 1, even though you have 2 zeros after the decimal, they still don't count. We only have 1 significant digit. Does that make sense? Okay. Last rule, trailing zeros. Zeros to the right of a non-zero digit are only significant if you guys see a decimal somewhere in the number. Okay. So if you have something like 560 grams, do you see how I don't have a decimal written? So that means that the 0 on the end does not count. It's not significant. I technically only have 2 significant digits. If you had 560 with the decimal point on the end, then the 0 on the end will be significant. And this would be 3 significant figures. Same thing if you have 560.0. The zeros on the end are significant if there's a decimal somewhere. I have a decimal somewhere, so that makes the zeros on the end, which is both of them, significant, and here I have 4 significant figures. Okay? Memorize these rules, practice them. You're going to have a quiz on this on Monday on Canvas. Does that make sense? Okay, we have an entire worksheet of practice. But before we get to that, what I want to do is take a look at the practice problems that are in your book. Okay, can I move this? No? Okay, okay. Okay. All right, so there are practice problems in your book with the answers that you can do on your own. I would recommend doing that for extra practice, but here are the practice problems, okay? Let's just do this out loud really quick. For number 1A, how many significant digits do I have? 3, okay. For B, how many do I have? Does the 0 in the middle count?
Yes.
Yes. Does the 0 on the end count?
Yes.
Yes, because I have a decimal. So here I have 5. C, how many sig figs? 3, exactly. Zeros in the front don't count. 0 on the end counts because I have a decimal, okay? For D, when you have a number in standard scientific notation, you only look at the decimal portion, do not expand it, okay? So how many sig figs do I have here in the 1.50? 3, yeah, because the trailing 0 counts because there's a decimal. How about E? 2, yeah, because there's no decimal there, so the trailing zeros do not count, okay? Now, you may sometimes see people abbreviate sig figs as F, or they'll write out sig figs. If you ever see me do something like that, that just means that your sig figs are wrong, okay? Okay, now, for rounding, for 2A, they want us to round to 3 sig figs, so I'm going to underline the 30.5. Since after the 5 is a 4, the 5 won't round up. So this would be 30.5 seconds with 3 sig figs, okay? For B, if I want 3 sig figs, I would underline the 289. The 5 after the 9 will make the 9 round up to a 0, which will make the 8 round up to a 9, right? So this would be 0.290 grams. For C, I want 2 sig figs, so I'm going to underline the 4.4. What would this become? 4.5. And then for D, this one's really tricky. I'm going to do this with you. For D, I want 2 significant figures, so I'm going to underline the 1 and the 0. Technically, there's no way for me to write this as an ordinary number with 2 sig figs, because if I make it 100 without a decimal, that's 1 sig fig. If I leave the decimal on the end, that's 3 sig figs. So you would have to put this in standard scientific notation like this to get it to 2 significant figures at one time. Okay. Now, take a look at the practice worksheet that I gave you. I gave you 20 practice problems with answers on the back for you to practice on your own time. Okay? So I will give you questions just like this on the quiz on Monday on Canvas. Sound good? Okay. Can I go on to the next topic? All right.